we're going to show you is how to bring up an amplifier that you don't know, is unknown, so this particular one is just freshly built. So we're going to show you how to bring it up on a variac to normal working voltage. The working voltage in Europe is 230 volts. So we'll show you to bring that up slowly. In our second video we will show you how to test the frequency response from it, which is the roll off on the bass end and the high end, high frequencies. Normal frequency response is measured at minus 3 dB down, but for the sake of the video we'll also show you how to test the 0 dB line, which is the flat response curve. And in the third video we'll show you how to test the output power from this video. My name is Graham Holland, I'm the owner of Audion, and this is our 2011 intern Kieran. Hello and welcome to the second part of our series of basic testing of valve amplifiers. Today we are testing an Audion Sterling Mark I EL34 stereo. This is a printed circuit board version. In this test we're going to show you how to check the roll-off frequencies, that's the high frequency and low frequency roll-off. For the test we have the volume control at full volume. For this test we will use a signal generator and a millivolt meter. The ammeter from the previous test we don't need, but we will need to use the oscilloscope just to show you what it's actually doing. So for the basic test we adjust the output to 1 volt. You'll see from the meter reading that it's 1.5 volt full scale deflection. So we're showing 1 volt here, which is the 0 dB point. At the moment we've got 1 kilohertz going there. So Kieran, if you go to the basic extremes, the bottom extremes, so we switch down to 10 hertz, you'll see that's now at minus 5.5 decibels. So we need to increase the frequency now, so it's approximately minus 3 dB down. So at the minus 3 dB down point we have about 12 hertz roughly. So we can, I mean it's 11 3/4, but it's 12 hertz for argument's sake. Now if you increase the frequency now until we get to the 0 dB point, you'll see the 0 dB point is around about 15 hertz. So we can say the flat line frequency response starts at 15 hertz, we say. Now we'll go up to the oscilloscope. You'll see at the 15 hertz mark it's a pretty even pattern. There's a little bit of distortion on the bottom end, but that's not a problem. That's because it's on the very, very low frequency. If we go back to the SIGGEN, we'll increase back to 1 kilohertz, which is still fine. Then we go to the next end of the spectrum, which is the 10 kilohertz mark. And you see from the oscilloscope, we change down again. That's a pretty even pattern. Now as we increase, if you increase the frequency to we start going off of the 0 dB mark, so the flat line response for this amplifier on 0 dB is around, let's just go back a little bit to just under 20k, so we're just under a quarter of a dB down at 20 kilohertz. So the flat line response for this amplifier at 0 dB is about 15 hertz to 20 kilohertz. If you carry on increasing until we're at the minus 3 dB mark, so we're at 50, 60, 65, so we're around about 68, 69 kilohertz. So the frequency response for this amplifier at minus 3 dB, which is a standard measurement for power amplifiers, is 12 hertz to 69 kilohertz. And you'll see again with the scope, you see it's a nice even response curve. It's pure sine wave in, pure sine wave out. So the next test we'll show you how to measure power output at 1